Hi guys, let's do a quick introduction to parabolas. All right, so we'll start with a little bit of revision. All right, so the first equation, if you see, it's y is equals to x, right? And y is equals to x is the equation of a line, right? So we'll go a little bit to the revision and then we will come back to parabolas. All right, so y is equals to x. If we have to plot that graph, right, we know that the y-intercept here is nothing. So it's plus 0. So that means it will cross through 0, 0, and it's x. So it is straight away in the middle because it's like one way. So the gradient is 1. So 1 over 1. 1 rise over 1 run. 1 rise over 1 run, if you remember the gradient, right? So gradient is equals to rise over run, right? So here, if it is 1, so it's going to be 1 up, 1 to the right. All right. Next graph says y is equals to x plus 1. So here, if I draw the graph again, our y-intercept is plus 1 this time. So that means the line is crossing through y is equals to 1. And gradient is 1 still. So that means the line is parallel to the line that we just drawn, just that it has moved up. All right, so it's parallel to that. It has just moved up. So here, that's the line. It's parallel to that line. So this line and this line here is parallel, right? Just it has moved up. Same line, move up, all right? And similarly, if you do x minus 1, it's going to come down, right? So this is moving up and down of the same line. What happens when we multiply 2? So it's now 2x. The gradient is, instead of 1, the gradient is now 2. So if we draw this, right, it is at 0. So it will pass through that. So its y-intercept is 0. But think about it. Is it parallel to the line that is above? Because the gradient has changed, gradient has doubled now. So rise over run is now 2 over 1. So you rise 2 and then you go right 1, rise 2, 1. So that means it is not parallel to the two lines that we have drawn above, but it is steeper. It is more steep, right? It is steeper this way. It's not parallel, it is steeper, right? So you can say that it is going towards the y-axis and it's steeper, right? Because the gradient has increased, the slope has increased now, right? Now, if we have x times x, what does happen now? So when we have x times x, or in a better way, we can write it as x squared. Let's see what happens. So the best way to find out what happens in an equation is by creating a table. You put in the values, put in the x values yourself, and you find the y value. And that way, when we plot those values, we can find the graph. So x and y, we can put as many values we want, right? So let's start with 0. 1 and 2. Let's have positive value. I'll tell you why I left the two boxes empty. So just stay, hang in there. Now here, when the x is squared, so when x is 0, your y value is going to be 0 as well, right? When x is 1, 1 squared is 1. When x is 2, 2 squared is 4, and so on. So when x is 3, it's 9, 4 is 16. Now, if we go on the negative side, if it is minus 1 and minus 2, so when x is minus 1 squared is equals to 1. And when it is minus 2 squared is 4. So here, if you look carefully, you can see that it is same on the right side and same on the left, right? So it goes in a palindrome way, if you know what that is. So it's similar to those words that you have, which is the same if you read it backwards. So like race car. So if you read it backwards, it's exactly the same as you read it straight, all right? Same is the way here, right? So same. If you remember what these are called palindromes, or in maths it's called palindromic numbers. I don't know the spelling. Numbers. Right? Palindromic numbers like 66, 111, 101, 1001, and similarly. So the number, when you read them backwards, is the same. Right? You can think of those numbers. There are a lot of palindromic numbers. All right. So this is a palindromic table, kind of. All right. So now when we draw the graph for that, if you draw a graph, 0, 0